Today on Capecci's Corner, we have some extra proof practice in our deductive reasoning chapter. In looking at our first proof, the given information is that angle 3 is supplementary to angle 1 and angle 4 is supplementary to angle 2. We are trying to prove that angle 3 is congruent to angle 4. So let's take a look at our diagram. We know that we have vertical angles, 1 and 2 are vertical angles, so they're congruent. Also, with the given information, we know that we have two different pairs of angles that are supplementary. So we know that when we add them together, we equal to 180. And that's actually where we're going to start with our next step. So step number 2, I'm going to say the measure of angle 3 plus the measure of angle 1 is equal to 180. And I'm also going to say the measure of angle 4 plus the measure of angle 2 is also equal to 180. And the reason I can say that is because of the definition of supplementary angles. Now notice when I wrote that, I wrote the M in front of the angle name because I'm talking about equality, so I need that M in front for measure. Now my next step, if I look at my previous step, step 2, I notice that they're both equal to 180. I have 3 and 1, when I add them together I get 180, and 4 and 2 when I add them to get to 180. So if they're both equal to 180, I can say that they are equal to each other. So I can say the measure of angle 3 plus the measure of angle 1 is equal to the measure of angle 4 plus the measure of angle 2, and that is because of substitution. I move things around since they're both equal to 180. Now my next step, I can go back to my vertical angles in my diagram. We know that angle 1 and angle 2 are congruent because they're vertical angles. So I'm going to say angle 1 is congruent to angle 2, and that is because vertical angles are congruent. Now I know I'm going to need to subtract here, so I need to change that to equality. So I'm going to say the measure of angle 1 is equal to the measure of angle 2. Now in certain books they want you to split that into two different steps, but I like to just keep it together. Now my last step, I know that I'm going to subtract. If you notice, in step 3, I have measure of angle 1 is on the left hand side, and I have measure of angle 2 is on the right hand side, and what I'm left with when I subtract them is 3 and 4 are equal, which is what I want in my trying to prove statement at the top. So I'm going to say that the measure of angle 3 is equal to the measure of angle 4, and that is because of subtraction. I subtracted out what I did in number 4, the measure of angle 1 and 2 are equal, and I need to change that equality back to congruency because that's what my proof statement is asking for. So I can say angle 3 is congruent to angle 4. In looking at our next proof, I have the given information is the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 3 is equal to the measure of angle 4. I'm trying to prove that ray YS is perpendicular to line XZ. Now my first statement, my given statement, I was able to put both given statements together. They're the same sort of idea. They're both smaller angles. They're both talking about equality, so I put them together in one given statement. With all proofs, we have to figure out where we're going and how we're going to get there. So let's focus on what we're trying to prove. I'm trying to prove that ray YS is perpendicular to XZ. That's a line. So we did a number of things with perpendicular lines, so we need to go through them again. Before that, I need something that's going to get me to perpendicular lines. So the definition of perpendicular lines, you need to state that either the angles are 90 degrees or they're right angles. Now, in looking at my given information and my diagram, I don't seem to have that, or I don't seem to be able to get there. I don't have any angle measures. So I have 3 different theorems. My one theorem says if two lines are perpendicular, then they form congruent adjacent angles. Now, the problem with that is I'm starting by saying that the lines are perpendicular. That's not what I'm doing here. I'm trying to prove that the lines are perpendicular. So that needs to be my conclusion, part of my if-then statement, not my hypothesis. So that one's out. My second theorem says if two lines form congruent adjacent angles, then the lines are perpendicular. Well, that sounds like that one might be a possibility because I'm concluding that the lines are perpendicular. Let's look at our other theorem. It says if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. Again, that one's not going to work because I'm talking about perpendicular lines as my if statement, my hypothesis, and not my conclusion. So it looks like I have to go back to the theorem that says if two lines form congruent adjacent angles, then the lines are perpendicular. So what that means is I have to somehow find that angles are congruent and adjacent. So if I'm looking at ray YS and line XZ, if I could somehow prove that this angle right here and that angle right here together in red, when I combine them, are congruent, they're definitely adjacent, then I can say the lines are perpendicular. So that becomes my new goal. If I can say angle XYS is congruent to angle SYZ, then I'm in good shape in getting them to perpendicular lines. So in a proof like this where it's a little tricky, sometimes it's a good idea to start from the bottom as well. So I'm going to make my last statement, YS, ray YS, is perpendicular to line XZ, because that's what I'm trying to prove. And my reason is, if two lines form congruent adjacent angles, then the lines are perpendicular. So now again, that's my best guess. If I'm wrong, I can always go back and make changes. And we also said that my previous statement, I need to say the angle XYS is congruent to angle ZYS. I don't know the reason now, but I know that's how I need to get there. So let's go back to the beginning. So I'm looking at my diagram. I somehow need to get 1 and 3 together, and I need to say that that angle XYS, is congruent to angle SYZ, which combines 2 and 4. If I look at my given statement, I have two equality statements, so I can add those. So I have the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 4. And that's going to be the addition property of equality. And the reason I put 1 and 3 together, because if you look at my diagram, 1 and 3 are going to form that angle XYS, and 2 and 4 are going to form the other angles. That's why I grouped those together. Now, I need to kind of combine them again. I need to get to this angle, these angles here. So what I can do through angle addition is I can say that the measure of angle XYS is equal to the measure of angle 1 plus the measure of angle 3. And I can say the measure of angle SYZ is equal to the measure of angle 2 plus the measure of angle 4. And that is going to be through angle addition postulate. Now I'm getting closer because now I see the angles I'm trying to get to. I have angle SYZ is here, and I also have XYS is here, and that's where I'm trying to go down here. So I'm getting closer. Now if you look at steps 2 and step 3, I have two different equalities, and I have measure of angle 1 and 3 are combined, and I say they're kind of equal on one side. And if you look at the other side, I have 2 and 4 here and 2 and 4 here. So through substitution, I can now say the measure of angle XYS, is equal to the measure of angle SYZ, and that reasoning is substitution. And if you look at that, I actually combined what I was trying to get to. I have equality here, and I have congruency here. I have the same angles. So I'm actually in good shape. I just need to finish this proof by numbering. So my step 5 states that they're perpendicular lines. And my reason is if two lines form congruent adjacent angles, then the lines are perpendicular.